Hello everyone. So we are now looking at the last example on this slides here, and looking at applying the derivative of the logarithmic function. So I guess you now already know that when you're looking at a log function, the derivative of y equals log base x, we end up with the derivative of that is 1 over x. All right. Now, the question here is asking us to look at this function here, and we need to sketch it. But to get to that sketch, we need to do a few things first. All right, so now there are about 6 or 7 parts to this question. Part A is to find the domain first of all. Right, so let's just think about this. The domain of a log function, well, think about a log function, just the basic log function, even like y equals that. Okay, hopefully you can see it up there in the corner. All right, so we know that the function is approaching the y-axis, so x equals 0, but it doesn't actually get to it. So what do we know about the domain of this function, the logarithmic function? X must be greater than 0. Okay, so that's the first part of the question. Part B is asking us to find whether this and state whether this function is odd, even, or neither. All right, for that, if you remember, we start with, well, for an even function, I'll just do it on the side here, f of negative x must give me f of x. For an odd, when I substitute negative x into the function, I end up with a negative f of x. So let's see if either of these work. So we start with the substitution of negative x into the function. So I end up with negative x log base e and then minus x. Now here is something that we need to think about. Okay, am I able to find the log base e of any negative number? And the answer is no. So the function is undefined here. Okay, when we have a negative, undefined. Okay, so what can we say then? This function is neither. Okay, therefore function is neither. All right, then we get to part C where it's asking us to find the zeros. All right, the zeros mean what? We need to find the x-intercepts. How do I find the x-intercepts? We let y equal to 0. If I let y equal 0, so back up here, I end up with 0 is equal to x. So two solutions. First one and the second one. Okay, now let's think about this one first. All right, well, we've just said in part A that the domain needs to be greater than 0. So this is not going to happen, right? But now I can figure out this one here, and this is in log form. Let's change this into in index form. So e to the power of 0 is equal to x. Now e to the power of 0 is 1. Okay, so when x equals 1, I end up with a y value of 0. And then I've already drawn up a table here just to look at and see what's happening at key points. So the first one, when x equals 0, right, y, no, we don't have an answer for y because we stated here that x must be greater than 0. So it's undefined, nothing's happening here. All right, now when x equals 1, y equals 0. And then I picked these 2 points on either side. They're key points. Now, why do you choose E? Now think about it. We're talking about the log function, log base E. All right, so I want to see, of course, what's happening. On this side of 1, I have the value of E. E is 2.718, da 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 da. Okay, so I choose E, and on the other side of 1, it's e to the power of -1. E to the power of -1 is a negative value, of course, and it happens to be -0.3678, and it's a very long decimal. So to the left of 1, we have negative signs. To the right of 1, we have positive signs. So when we sketch this function, we're going to come back to this. Okay, now I'm going to stop the video at this stage. Oh, I just wanted to write up here. Oh, how do I get those y values? That's what I want to state. That's right. So when x is equal to e to the power of -1, I need to find the y value, right? So how do I do that? I substitute x for e to the power of -1. So e to the power of -1 times log base e, and that's e to the power of -1. Now remember this very, very important rule when we looked at log laws, that this -1, I can bring it to the front here. So this becomes e to the -1 times -1, and then I have log base e, and remember another log law, that equals 1. So I end up with e to the power of -1 times -1 times 1, which gives me negative e to the power of -1. And that's how I end up with that value. Okay, how do I end up with this value here? Well, let's just have a look here. Right, substitute back into the original, e log base e, and then x is e. So remember, that's equal to 1. So that's e times 1. So therefore y equals e. And that's how I end up with that second e. So we wanted to make sure that you understand how we end up with the y values. Now, what does this table tell us? Okay, we write just a short line here. What is it telling us? All right, that y is negative when, okay, let's have a look. Y is negative over here for x is greater than 0. Actually, I should write it this way. All right, when x is greater than 0, but less than 1. Okay, and y is positive, right, for x is greater than 1, right? So we have between here and here, we have a negative function, and then because we have when x equals 1, y equals 0, but then we have the positive on this side, and e is greater than 0 because e is 2.718 and so on. Okay, I'll stop the video now so you can just take all this in and copy down any notes that you need to copy, and then the rest of the solutions or the rest of the answers to these questions will be on the next video.